Very good morning to all of you. How are you? I hope you all are fine. So let's discuss about the next topic, that is your potentiometers application. But before proceeding with the application, I'm going to revise that what we have studied in the previous class, that is about the potentiometer. So I told you earlier that the potentiometer is not a device. It's first of all a circuit. Okay, and why it is used? It is used for measuring potential difference across the wire. Okay, so why voltmeter is not used? Voltmeter is not used because it does not gives us the exact value of the potential difference. So that's why the potentiometer is going to used. As I told you that the setup is something like this is what we have: the voltage fixed in it, this is your internal resistance, this is the key which you have to plug in, plug out. Okay, this is your resistance box, which with the help of which you can choose the value of the resistance, and this is the wire whose length will be measured by you with the help of scale. Now it works on the principle of, again, that is your null point or null deflection method. That is, the current through the galvanometer should becomes equals to 0. Okay, so as we have studied that when the current through the galvanometer is going to be 0, in that case the potential across the wire VAB, that depends on its length totally. So this is what we have done in the previous class, and I know, and I'm going to repeat only this, that here the terms comes that is known as potential gradient. Now what is potential gradient? That means variation of the potential with respect to distance. So that's why its value, if you want to calculate its value, it is sigma is equals to V upon L. That means potential upon its length is termed as potential gradient. Okay, so we have known that how we will calculate the EMF of a battery also, that is potential gradient and its distance. Okay, now today our aim is to discuss about the applications. Okay, now applications of potentiometer. I told you earlier that there are two kind of application there is for the potentiometer. So first is your to calculate the internal resistance, okay, of unknown battery. The battery that is given to you, you have calculated its EMF, no? Now your aim is to calculate the internal resistance of that unknown battery. So our setup will be like this. This is what we have. This is the wire AB. Okay, this is the wire AB, and what you will do, you will connect the battery here with a known EMF now. Okay, because you have calculated it, no? So that is your known EMF. Okay, now here what is there? There is a kind of resistance also with this. Okay, and here the galvanometer is also being connected to it. This is your galvanometer. Its one part is going to slide over the wire. Let's say here we have slided, this is your jockey. Okay, this is the point A, this is the point B, and this is the first term, right? Now connect resistance box parallel to the battery. Now what you have to done in this is the previous arrangement also, but in this case what you have to done is you have to connect the resistance box here parallel to the battery given to you. Okay, so what you have done, you have connected the resistance box parallel to the battery whose EMF is unknown to you. Now what you will do, you will take the resistance in from the resistance box. Okay, so case 1, let's say in first case you plug out, that is you take out, or you can say, okay, the resistance value infinite. Okay, what you have done, you have taken the value of resistance as infinity from the resistance box. When you taken the resistance infinity, then you know that resistance is the property that will allow the opposition of current. If resistance is infinite, that means it does not allow the current to pass through this circuit. Okay, no current will flow through this resistance box. Here the current is not going to flow. Okay, if we move jockey, now what you can do is you can move jockey over the wire, and if you are going to move jockey through the wire, we have only, because this is not working, so we will get the value of E. Okay, so we will move the jockey till the galvanometer gives 0 deflection. So let's say that we have a null point at the length L1, let's say. Okay, what we have done, we have plug out the resistance, that is infinity. When we are plug in resistance infinity, this is not going to work. So whose value we are getting? We are getting the value of only EMF of the, say, EMF of it. Okay, so when we are moving the jockey, we get EMF, and EMF as we have calculated earlier also, that is sigma x. Here it is x because the length is x, but here it is L1, so that's why E is equals to sigma L1, right? Give it equation number 1. Okay, now case number 2. Now what will you do? This resistance will be taken as R. Now this is not infinity. Okay, this resistance is not going to be infinity. Let's say its value is like 3 ohm, 4 ohm, 5 ohm, whatever you want to choose. You can choose the value from the resistance box, but it is not infinity. Now if it is not infinity, that means current will also flow through resistance box. Okay, then it is not E. When the current will flow through the resistance box, then it is not equal to E only. Okay, then it will be equals to its terminal potential difference. Terminal potential difference is denoted by V. So that's in the case when you choose the resistance that having some value, in that case the value of E is not there. In that case the potential difference is developed across this wire, and that terminal potential difference is to be written. Now let's say you have moved the jockey and null point acquire, let's say here. Okay, so let's say this length is equals to L2. Okay, this length is L2. So now we will get V is equals to V, as we know by the principle of potentiometer that potential is directly proportional to the length, and because I said that null point comes at the point L2, so that's why we have written this. Okay, now V is directly proportional sign is being removed by potential gradient, that is sigma L2. Give it equation number 2. Now we will calculate the ratio of first divided by second gives, that is E upon V, that is sigma L1 and sigma L2. Sigma and sigma is going to be cancelled, and E upon V, that will be equals to L1 upon L2, right? Now what is the value of E in terms of the current? That is I, okay, and that is R plus R, that you have calculated in previous lectures. Okay, and V is always equals to I R. So here L1 upon L2, I and I is going to be cancelled. Just cross multiply then this by this and this by this. So we have RL2 plus RL2 is equals to RL1. Now your aim is to calculate this. Okay, so RL2 is equals to RL1 minus RL2. Okay, now what you will do is RL2 remain it here, here R is common, take L2 also common, so you have L1 upon L2 minus 1. Okay, L2 and L2 is going to be cancelled out. So what is the final expression you will got for the internal resistance? That is R is equals to capital R, and this is L1 upon L2 minus 1, right? So this is the way you will calculate the internal resistance with the help of potentiometer. So I repeat my words, what we have done in the first case, we have plug out the resistance as infinity. When the resistance is infinity, that means the resistance box is not going to work. In that case, the value of EMF we will get, and that is equals to sigma L1, because jockey is giving deflection at the point L1. Okay, in the similar case, when we are putting the value of the resistance, let's say any value that is R, it is not going to give us the value of E. In that case, the value is given as the terminal potential difference. So terminal potential difference is always directly proportional to the length where the galvanometer gives 0 deflection. So let's say the point is here and this length is L2. So that's why I have written V is directly proportional to L2, and directly proportional sign is removed by sigma, so sigma L2, and this is the way we divided, and we know that the EMF is always equals to IR plus R, and that is why we have simplified, and this is the value we will got with the help of this. Okay. Now next application of this is, that is your comparison of cell. Okay, now next is your comparison of cells. What your aim is? Your aim is to compare the cell. Now when you are comparing the cell, let's say the structure is again like this. This is the wire you have. Okay, now here the EMF of the battery, which you are not known. There is the key, that is key 1. Okay, and here the galvanometer is going to be connected. Okay, and this is the jockey. Now jockey will give the deflection, that is your null point will be there on that case. Okay, this is your galvanometer. Here the two cells is to be going to be connected. So first is E1 and the second one is E2. Again here the next key is applied, that is key 2, and this whole connection is connected with the galvanometer. Okay, so case number 1. Now case number 1, key K2 is going to be open. Here it is not closed, it is going to be open. Then if K2 is open, that means current is not going to flow through it. Okay, current is not going to flow through it because it is open. So which one is working? That is E1 is working here. So if K2 is open, E1 is going to work here. Okay, slide the jockey till the deflection point occur. Okay, let's say the deflection point or the null point occur at the length L1. So here E1 will becomes equals to sigma L1. Right, give it equation number 1. Okay, similarly now case number 2. What happened to the case number 2? Here K1 is open. Again, if K1 is open, then it was not going to work any. Here it is not going to work. Which will work? E2 is going to work here. Okay, move the jockey till deflection point or zero deflection will given by the galvanometer. That means E2 will be equals to sigma L2. Let's say when we moved here the deflection comes and this length is L2. Okay, so that's why we have written L2. Okay, now we will calculate the ratio as previously done. E1 and E2 is equals to sigma L1 upon sigma L2. Sigma and sigma is going to be cancelled out. Okay, so in order to compare the EMF, let's say if we want to calculate the EMF of the first cell, then you will calculate as L1 L2 and this is E2. This is the way you are going to compare the EMF of the cell. Clear? So this is the way you have to do you have to solve the application here. In the books there is so much complicated things will be given to you, and with the help of this video you can understand betterly that how you will calculate the EMF of the cell or compare the EMF of a cell. Okay, now let's say one numerical is there. Numerical we can solve with the help of potentiometer. There are lots of numerical comes by the topic named as potentiometer. So let's say in a potentiometer arrangement, for determining the EMF of a cell, your aim is to determine the EMF of a cell. The balance point of a cell in open circuit is 350 centimeter. Now balancing point, that means L1. Balancing point क्या हुआ? Where the galvanometer gives the zero deflection. So that is 350 centimeter is given to you. When a resistance is 9 ohm. Okay, fine. Used in an external circuit of the balance point shift to 300 centimeter. Okay, that means balance point shift to 300 centimeter. That means this. Determine internal resistance. So internal resistance is calculated by the formula, that is L1 L2 minus 1 and this is capital R. So what is L1? That is 350 and this is 300 minus 1 and R is 9 ohm. So that comes out to be 350 minus 300, that is 50 upon 300 into 9. So that is 1 upon 6 or 9 upon 6. So 3 3s are 9, 3 2s are 6. Your value is 2 1s are 2. Okay, 2 5s are 10. Okay, so 1.5 ohm. So this is the way you have to calculate the numerical here. The formula should remember to you. I hope you liked the video, enjoyed the video, and go through the video and do the numerical yourself in order to get perfection in these topics. Thank you and have a nice day.